All right, so for our final exam review, part one, unit one, linear functions. All right, so all linear take the form of y equals mx plus b, unless of course they're in standard form. M is the slope, b is the y-intercept. Okay, you can always write your y-intercept as 0, comma b. Okay, so if it's that's how you write it as an ordered pair. Linear functions make straight lines. The y-intercept is where it crosses the y-axis. Okay, so looking at this function right here, y equals 1/2 x plus 1. It has a y-intercept of 0, comma 1. And it has a slope. Change in y is up 1 to the right 2. So it's a slope of 1/2. So up 1 to the right 2. So slope is the rate of change. Rise or run. I don't like that phrase at all. Change in y over change in x. Okay? Because sometimes it goes down. It doesn't always rise. Next now statements can be written as next equals now plus the slope at the y-intercept. Okay, so the next now for this one would be next now equals now plus 1/2 is 1 by 1/2. This one started at 1. Okay. So that's the first example of our linear functions. All right, so, well, that was the introductory. Example number 1. Select the linear expressions that have the same slope, that have the same rate of change. Okay. All right, so this m is 1/2. Okay. All right, let's look at this change in y over change in x. All right, this change in y is going down to, wait, it looks inconsistent. From 1 to -3 is -2. -2, then to -7 is -4. -4. Okay, so this is non-linear. Well, 4, 5. Ow. Well, let's just use these two. This doesn't work. This is not a good example. Okay. This is a change in y of 1. And a change in x here equals 1. Change in y here is -2. So our m here is -2 over 1. Okay, so that equals -2. Okay, part D. So our change in x here equals 1. Our change in y is 7. They're all going up 7. Okay. Looking at E, well, let's look at C first. All right, this is 3.5. We had a nice clean point here at 3. We have another clean point here at 2. So this is going down 1 to the right 2. Okay. So our change in y equals -1. Change in x equals 2. So here m equals -1/2. Okay. All right, so for E, well, F is going to be super easy because this is the slope here. That's 1/2. So m equals 1/2 for F. That's easy. And now E, we got to do a little bit of work for E. Okay, so for E, we have -x equals 2y plus y, excuse me, -x plus 2y is equal to 14. And then, so we're going to move x over to the other side. It becomes positive. Okay, we're going to divide everything by 2. 7 plus 1/2 x. 1 divided by 2 is 1/2. Okay, so who has the same slope? Looks like F has a slope of 1/2. E has a slope of 1/2. And A has a slope of 1/2. So those three all had the same slope. B came out to -2, D came out to 7, and C came out to -1/2. So that would have been close, but it was negative for part C. So those three had the same slope. Example 2, match given information or rule with each graph. Okay, so here we have four. We have 4 graphs. Okay, we have a whole bunch of them. We got a bunch of them with a y-intercept of -3. Got a couple of them with a y-intercept of -3, and somebody with a y-intercept of -1. Okay. So let's look at the one with -1. So this guy with -1 is going to go down 1 to the right 2. So in that case, m equals -1/2. So it has a slope of -1/2 and a y-intercept of -1. So boom. Here we go. Slope of -1/2, y-intercept of -1. So I would say this is L2. Okay, L2. So we got that one done. Okay, line 2, L2. Okay. All right. Everyone else has to have a y-intercept of -3. Okay. Negative. So this one has a y-intercept of -2. So it's gone. -1. It's gone. So we're down to A, B, and C for the last 3 lines. And the only thing that's going to differentiate those 3 is their slopes. Of those 3 lines, L4, this one L4 right here, is the only one that's going up. So L4 is going up. Well, this one's going down. This one's going down. This one does have a positive slope. So this B is going to be L4 because it has a positive slope. Okay, so L4 is accounted for. Okay, we've taken care of L4. Now we're down to A and C, and that's going to be either be L1 or L3 based on their slope. Because the only thing that's going to be different about these 2 graphs. All right, let's look at the red one, L1. It looks like it goes down 1 to the right 2. So it would have a slope of -1/2, and that looks like A. So L1 is going to be A. Okay, so that works. And process of elimination tells us that L3 is C. Okay, L3 is C. And we just confirm with the slope. It has a -2/1. So that slope will be -2/1, which equals -2. And to confirm, we have -2 for the slope of C. Okay, example number 3. Circle all expressions that are equivalent to 6x plus 18. Okay, so we're going to have to do some reduction here. Well, this one has a b value, so this has to go. We don't have any b values. We wouldn't have anything to do with that b value. All right, part B, looking at part B. Okay, this will be 15x minus 6 minus 9x plus 24. Okay, so 15 minus 9 is 6x, and then -6 plus 18 is, -6 plus 24 is 18, and that works. So B works. All right, C, we have 4x minus 12 is -8x. That doesn't work because we need 6x. Here we have -10 plus 4 is -6. That won't work. Okay. Okay, here we have 12 minus 6. That might work. Okay, 12 minus 6 is 6x. 27 minus 9 is 18. That works. And here we'll have 5x, and so this is 5x, and that's minus 11. That equals negative 6x, so that won't work. So F won't work. Okay, so the ones that work here are B and E. Okay, B and E work for this example. Okay, number 4, solve the following for x. So here we have 3x minus 12 minus 10 is equal to 5x. And we have, in this case, 3x minus 22 is equal to 5x. Subtract 3 from both sides. Minus 22 is equal to 2x. Divided by 2 is negative 11. Okay, so here we have minus 5x plus 6x minus 22 is equal to negative 28. So distributed 2.
Okay.
Okay, then we have x minus 22 is equal to negative 28. Add the 22 over, x is equal to negative 6. Okay, here we go, part C. I'm going to distribute the 5. 7x plus negative 10x plus 40 is equal to 25. 7x plus negative 10x is negative 3x. Plus 40 is equal to 25. Subtract 40 from both sides. Get negative 15. X equals 5. We divide by negative 3. Okay, here we need to distribute the 6. 4x plus 2 is equal to 6x minus 15. Okay, subtract 4x from both sides. 2 is equal to 2x minus 15. Add the 15 over. We get 17 is equal to 2x. Divided by 2, x is 8.5. Okay, number 5. The figures below represent the second and third stage of a pattern. Okay, so the easiest thing to do is count 1, 2, 3, 4, 5, 6, 7. Okay, so it'd be 3, 7. And stage 2 would be 1, 2, 3, 4, 5. Okay, and it says of a pattern, we're assuming it's linear. Okay, so this is what's given. We can extrapolate out further the previous stages. Okay, it looks like it's counted by 2, so this would be 3, this would be 1, this would be 9 and 11 if we want to go that direction. Okay, so how many triangles would be for the 10th pattern? Well, if we get a linear equation from this, y equals our change in y equals 2, change in x equals 1. So that gives us an m of 2 over 1, which is 2. And so in our we start at this point 1 here. So we end up with 2x plus 1. And on the 10th stage, okay, y would equal 20 plus 1, which equals 21. Okay, and we already had the table, create a table. So this was the next 4th and 5th stage there. Okay, so create a table, and I'll write that again so it's pretty. Okay, our next now is going to be next equals now plus 2, starting at 1, and the equation we already have at the top, y equals 2x plus 1. And I'll do okay, we can do the table here, there's enough space for it. So x and y, which is really, x and y really represent stages, and you can call them diamonds. Okay, what we were given was stages 2 and 3, and we have 5 and 7. We assume the pattern is the same everywhere, and so we can just work forward or backwards based on what direction we choose to go. And our equation y equals 2x plus 1. And we can use that equation to predict any stage without knowing where we are, without physically counting.